I'm JMT. I'm here to help you out with some U-substitution for the calculus exam coming up next month. So here's gonna be the question for the day, guys. So first, we're doing U-substitution, so you gotta find the U and then the du, but make sure you take this note away. U is usually in some type of grouping. So then with that being said, we have grouping of x third plus 4 in the parentheses, so we're gonna use that as our U for the day. And du is a derivative of that, so let's go ahead and find the derivative, guys. You can do it. And can't forget to bring the dx over in the du. So then let's go ahead and plug in our u and our du right now. And then after this, you just gotta remember, you gotta raise your roof and support that foundation, guys. That's what we gotta do next in the steps. It's the next one. I got you though. I'll help you with it. So you got u, and you're gonna raise that roof. So that's gonna be u to the 101th power. And you can put that over 101 too, guys. You could do it. I got faith in you. I do. And then after this, you gotta make sure that you plug back in your u. Okay, guys? Write a little arrow over here for you. Don't worry, I got you. You get the help that you need. So looky here. You got x cubed plus 4. Gotta put that in parentheses though, can't forget that. And then you gotta, you feel me, put it to the 101 power. You gotta put all that over 101. At the end of the day, you can't forget the constant, so you gotta add c to that. And that
Hi, I'm Miss Ayan. Okay, class, today we are going to learn about U-substitution in cross-section volume. So this is a FRQ from 2009, and I chose number 4. And it's saying, let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared as shown in the figure to the left. So we're going to work with this figure right here. Okay? So for A, it says to find the area of R. So to find the area, we're just finding this R region, okay? So our integral is going to start from 0 and it's going to end at 2, so because it's with respect to x. So how you would write it is top minus bottom. So the top being the straight line, which is 2x, minus the bottom, which would be the x squared function that we were given at the top, with respect to x as always. And after that, you have to support, raise the roof, support the foundation, and derive it. And you would get x squared minus x cubed over 3. And then we have to evaluate it. So we're going to evaluate from 0 to 2. So f of b minus f of a, we would plug in 2. So 2 squared minus 2 to the cube divided by 3, and obviously when you plug in 0, it's going to be 0. So 0. And then this one would equal 4, but we need it in a fraction, so we're going to change it to like 12 over 3. Minus 2 cubed is 8, 8 over 3, so 12 over 3 minus 8 over 3 equals 4 over 3. Did you guys get that? Any questions? Okay. B, this is the equation that has the U-substitution, right? So it says the region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has area A of x equals sine pi over 2 of x. Find the volume of the solid. So this tells us that this is acceleration, and in order to find the volume, volume is going to equal this with respect to x. Alright. So we're going to still integrate from 0 to 2 since it's still with respect to x. And then we have our equation. Okay. But, you can't solve that. I mean, unless you can, but I can't. So U-substitution, we would use U in our grouping, which is pi over 2x. And then the derivative would be pi over 2 dx. But since there's not another pi over 2 in this equation right here, we are going to move it to the other side and leave dx by itself. Sorry, I forgot the dx. Okay? And then we're going to bring that and just plug it in the equation back as it was, so it'll be sine over u. And we have our 2 pi du, so you can put the 2 pi in front of the interval, and then du. And then we would evaluate from there. So then you would have 2 pi times cosine, because we took an antiderivative, right? Cosine of pi over 2x, you plug in back your u, and then you plug in 2, and you plug in 0. So when you plug in 2, you would have cosine of pi, which is -1. -1 times 2 over pi is -2 over pi. So minus 0. Cosine of 0 is 1 times 2 over pi is 2 over pi. So -2 over pi minus 2 over pi equals -4 over pi. Okay. Solid has the same base R. For this solid, the cross-section perpendicular to the y-axis are squares. Write but do not evaluate. Okay. So we're just going to write the equation, and since this is revolving volume, you have to remember we always have pi, right? And this one says with respect to the y-axis. So we're going to use our y scale. So it goes from 0 to 4, which is right here. And then to find the area with respect to y-axis, you would have right minus left. Okay? Okay, but we need this in terms of y. So this y equals 2x up there, and y equals x squared. You would have to set it so x is the other side. So you would divide by 2, right? And you would square root. And that's how I got the x equals y over 2 and the x equals square root of y. And since the right one is this one, we're going to use that minus y over 2 squared, because we're using squares, and the formula for a square is s squared. So here's our s, and here's the square with respect to dy. Any questions? All right. Thank you, class.